Hello, and welcome to this video introducing composite functions. Because a function is a process that converts a collection of inputs to a corresponding collection of outputs, in certain situations, we can combine two of these function processes consecutively in order to produce one new overall process. For instance, if we have a draining tank and are able to develop a first function that processes time value inputs to produce the corresponding height of the water in the tank as output, and then develop a second function that processes height of the water inputs to produce the corresponding volume of water in the tank as output, then it's possible to generate a third function that combines the first two in order to simply take time input and produce the corresponding volume as output. There are two important ways to think of such combined processes symbolically, through arrow notation and through function formulas. With arrows, we might write things like F:(t) arrow h and G:(h) arrow v to represent the functions that take time inputs t to height outputs h and take height inputs h to volume outputs v. Then there's a corresponding function little h such that little h takes time inputs t to volume outputs v. In the notation of function formulas, we'll write things like h of t equals g of f of t as what we call the composition of g and f. In this section, you'll study the ideas of combining two functions through composition from several different perspectives. In abstract settings with algebraic functions, in applied settings where the physical context helps connect the processes, and in connection to the average rate of change of a function.